All right. So, when I was thinking about what should I do my next intervention video on, I wanted to pick something which could effectively target everybody. So that's one thing. And I wanted to have something which would be useful for the upcoming assessments that we've got. And I wanted to pick something that I thought that students can perhaps do just that little bit more effectively. I've spent a lot of time thinking about how I'm going to do this, and I think I'm going to do this essentially just by looking at even the most straightforward of questions, but looking at the most efficient way of doing particular questions. Okay, we're going to look at using our calculators, and I've got my trusty little on-screen calculator here as well, so we can go through things. And we're going to take a look at how I would approach the most straightforward percentage questions and even the most complex percentage questions in the most effective way. Okay, and I hope that makes sense. But we're just going to jump into it, and you'll see what methods I start to employ. So we're going to start off with reminding ourselves about a particular thing. The multiplier. Okay. Our multiplier is a total percentage, and that could include an increase or decrease, written as, and I've put in quote, a decimal. And what I mean is that it's not a percentage quantity. It's been divided by 100. Okay, so that's the first thing. We need to divide things by 100 in order to get our multipliers. Okay. So, if I'm wanting to find 17% of 84, that's not an increase, it's not a decrease, it's just 17%. So I would want to know what is 17% as a decimal. Well, dividing that by 100, we'd get 0.17. Now that is a multiplier, and the key is in the word multiply. What we're going to do is we're then going to do 0.17 times by 84. And, okay, 0.17 times by 84 equals 14.28. Okay, that's going to be a thing. All right, 14.28. Okay, and that is, straightforward enough. I would expect people in, year 8, year 7, year 9, all the way up through to year 11 to be able to do questions like that. And you might approach that by finding 10%, finding 1%, and it's a good non-calculator method, but it is very inefficient. Okay, we're focusing on the most efficient, the quickest methods of doing something. So the second one, find a 32% increase on 134. The thing I got to realize, it's not just 32% anymore. It's a 32% increase, which means that I've started with my original amount, or 100%, and I've added on 32%, which is 132%, which as a multiplier is going to be 1.32. This makes sense because if I multiply by a number which is bigger than 1, my answer will be bigger. And that should be what I expect because I'm doing an increase. So I'm doing 1.32 times by 134. And here we go. 1.32 times 134 equals 176.88. Happy days. Similar thing for this one, only instead of an increase, we are on a decrease, which means that we start with 100%, and this time we're taking off 101%, which is negative 1%. You might think, is that even possible? I suppose technically it is possible. It's not very common, but it is possible. Which, as a decimal multiplier is going to be 0.01, negative 0.01. So my answer to work this out is going to be negative 0.01 times by 17.5. And calculator time, negative 0.01 times by 17.5 equals negative 0.175. Negative 0.175. Okay, and you might have been able to see that from just saying, oh, I could just divide that by 100 and make it negative. Okay, so I'm going to give you a chance to pause now. You've got your examples on the left-hand side. I would like you to see if you can work out the ones on the right-hand side. So I'll give you a little bit of time to pause. Okay, here we go. So I'm going to clear off my calculator. I'm going to write down the calculations that we should have looked to do. So no increase or decrease. It's just going to be 0.57 times by 157. So 0.57 times 157, which gives us 89.49. 89.49. 32% decrease, so 100 take away 32 is 68, which is going to be 0.68 as a multiplier. So I'm going to do 0.68 times by 32. And typing that in, 0.68 times by 32 is 21.76. Oh, sorry, 21.76. And lastly, 105% increase this time. So we're going to have 100 plus 105 because we're looking to increase, which is 205%. 2.05 is going to be our multiplier, because to get our multiplier, we divide by 100. And then we're going to do our multiplier times by our amount. There we go. So 2.05 times by 12.5 is 25.625. 25.625. Here we go. So those are our basics things, and if we're looking to do percentages quickly, effectively, this is the method that I would look to employ. When things start to get a little bit more difficult is where we might have to do a percentage increase over and over again, or a decrease which happens over and over again. Okay, and that's what we're going to look at next, what we call a repeat percentage change. Now, you can see here we've got multiple different things going on here. Even though in the first one we've got a 15% increase after a 34% decrease. Now, what we're going to have to do is we're going to have to consider each of these things separately. So I'm going to have to look at what a multiplier will be for a 15% increase, what our multiplier will be for a 34% decrease, and then look to do them successively. So a 15% increase is going to be 100 plus 15, 115, divided by 100 gives me 1.15. And then I've got a 34% decrease, so 100 take 34, which is 66. So it's going to be 0.66. Now, to work out what my overall amount is going to be, I'm going to have to multiply by these multipliers, just one after the other. So I would have to do 150, which is my starting amount, times by 0.66, times by 1.15. And that will just give me my answer. So here we go. So we got 150 times by 0.66 times by 1.15, 113.85. 113.85. Now, this is measured in pounds, so we would only go to 2 decimal places. I would not go any further than that. Now, the second question that we've got here is what we would actually call a compound interest question, for no reason other than you're just doing the same percentage over and over again. You could also call this a repeat percentage change. Now, here we've got a 3.5% interest rate, but this time it's invested for 5 years. I should really have an additional thing here, which is that I should say that this is a 3.5% interest rate measured per year. So it just means that that percentage only happens once per year. Okay. Now, I still need to think of my multiplier. That has not changed. Okay. If you're investing, your amount should be growing. So we're going to be looking to do 100 plus 3.5 to make sure that it grows, which is 103.5. And then as a decimal multiplier, 1.035. Don't forget that 0. The amount of students that I will see that will miss out that 0 and put 1.35 instead is higher than I would like. Okay. Now, this is happening 5 times. And it would technically be correct, but a lot of writing, if I wrote 2000 times 1.035 times 1.035 times 1.035 times by 1.035 and finally times by 1.035. There's nothing technically wrong with that. It does the job. However, it is inefficient, and we are trying our best to be the most efficient that we can. So rather than saying 2000 times 1.035, etc., etc., I'm actually going to abbreviate this. I'm going to shorthand it to 2000 times 1.035 to the power of 1, 2, 3, 4, 5. Okay? And that might have been obvious to you, which, you know, if that is the case, good, because at this stage we should be definitely aware of this. So 2000 times 1.035 to the power of 5 equals, and then that would be our answer. So we've got 375.37. And again, this is money. So all of those decimal places that appears after the decimal point, I only need 2. I only need 2. Okay. Now, this bottom question is actually quite interesting. I'm asking this time for the overall percentage change, and we've not been told what the original amount is. And that's because we don't actually need it. What we actually need to do is we actually need to just look at the percentage increase. Now, we've got a 2.5% increase. So 100 plus 2.5, 102.5, nothing special there. Multiplier, again, nothing special there, just becomes a 1.025. This is being actioned 5 times overall. Now, using the idea that we had in our second question, that means we can write 1.025 to the power of 5. This is what we're going to use to find out what our percentage change is going to be. So if I do 1.025 to the power of 5, I get 1.131. Now, this was a 2.5% percent increase. This is going to be a 13.1% increase. Okay, and that is what our percentage change will be. It's going to be a 13.1% increase. Okay. Now I'm going to have to move my calculator for 1 second so that you can see the questions, and I'll give you a chance to pause, try out those questions on the right hand side now. Okay, so hopefully you've had a chance to pause there. And now I'm going to go through these questions. I'm not going to have my calculator on screen. I'm going to use my calculator in front of me in real life. So, calculate a 20% increase, 28%, sorry, after a 15% decrease. Got to know our multipliers. So that's going to be 1.28. This is going to be a 0.85. So we're going to have 225 times 0.85 times 1.28, which is 244.8. Now, money, so 244.80. This is a compound interest question, like a very standard compound interest question. We're investing, so we're expecting things to grow. We got a 5.4% interest rate. Again, this should say measured per year. And it's invested for 7 years. So we're going to do 2,000, and I'm going to just jump straight to the shorthand for this one. It's going to be 1.054 to the power of 7. So 2,000 times 1.054 to the power of 7, which is 2890.11. And I've rounded that up at the very end because money should only have 2 decimal places. Lastly, the overall percentage change for a 2.5 increase followed by a 5.2 increase. Okay, so we've got 2 successive multipliers. A 2.5% increase would be 1.025. And a 5.2% increase will be 1.052. Timesing them together, because they are both multipliers, we'll find an overall percentage change. And I just type that into my calculator, which is 1.0783. Now, make sure to interpret what this means. This is a 7.83% increase. Okay, if it was a decrease, say like we ended up with a number which was 0.987 as my final answer, I would have to see how far away this is from 1. Okay, so what this would actually be is a 1.3% decrease. Okay, because 0.987 plus 0.013 gives me 1. Okay. What you can do at this stage, if you find that bit particularly difficult, take away 1. Because what that will do is it will take away the original amount, even if we don't know what that is. In terms of the multiplier, taking away 1 will take away the original amount. Okay, so for this one, we'd end up with 0.0783, and this one we'd end up with 0.013. Okay. So we've still got a couple of things that I want to look at now, because we're looking at everything that we could want to look at to do with percentages, and we've still got time. Where things start to change, especially on the crossover side of things, as you start getting into higher tier, is where we want to try and reverse this process. And we've got to think about this quite carefully. What we have done over the last couple of slides is think that our original amount, excuse me 1 second. Oh, sorry about that. We thought that an original amount times by a multiplier should equal our final amount. So if we try and reverse the process, we will want to try out and find out our original amount, and we will know our multiplier and our final amount. And there will be an extra step to it. So let's see what we got. A coat is 20% off. The price decreased by £15. What was the original price of the coat? So there's actually a couple of ways you could do this. I'm going to do this both ways because they're both pretty efficient with this. We have taken 20% off and the price has decreased by 15%, which means that £15. So £15 equals 20%. To find an original price, we're looking at finding 100%. Now, we can just ask ourselves, what do we have to do to get from 20 to 100% by multiplying? And if you said times by 5, then we've got to times 15 by 5, which would be £75. And that's quite nice if we're talking about a calculation that we can do in our head. But what if it was a situation where we couldn't do it in our head? For example, if the numbers were slightly more awkward. Well, what we could do is we could say that because we know that 20% of our amount gives us 15, because 15 is 20%, I know that my original amount that I don't know times by 0.2 equals 15. Now, if I was trying to work out what this mystery number is, I could do 15 divided by 0.2, which will be 75. So this left-hand method uses kind of the multiplier stuff that we've been looking at so far. The right hand is looking at things about proportion and stuff like that. When things sometimes get that little bit more awkward, the left-hand method can become a bit more efficient. For example, the bottom question. An amount has been increased by 15%, and it is now £1,515. What was the original amount? Okay. And again, you could do this by proportion. You could say that if we have increased by 15%, that means we would have 115%, which equals £1,515. And you might have to go through some intermediate steps before getting to 100%. I personally wouldn't do this question this way. I would probably do it using my multipliers. So then I could just say, if we've increased by 15%, that's going to be a 1.15 multiplier. If you're not sure where that 1.15's come from, we've done 100 plus 15 to get us 115, then divided by 100 to get 1.15. And that equals 1515. And at this point, now it should be kind of clear to say that our mystery number will be 1515 divided by 1.115. Sorry, 1.15. So, 1515 divided by 1.15. My calculator says that this is 1317.39 to 2 decimal places. And we can check that. We can put that back into the top line to see if it works. So I could type 1317.39 times by 1.15 and see if it gives me 1515, which it does when rounding. To to do the question on the left, I would probably find out what 1% would be by dividing by 115. And then times by 100 to get my 100%. But that is effectively doing what this left-hand side is doing. Okay. I think I would probably use the left-hand side to do this. So, once again, 3 questions on the right-hand side. I would like you to try those questions. I'll give you a moment to pause. So here you go. Alright, so if you've not paused, you're kind of missing your chance. But we're going to look at these questions now. So, bag is 15% off. The bag decreased by £45. So that means that those two amounts are equal. So, our original amount times by 0.15 equals 45. So x will equal 45 divided by 0.15. 45 divided by 0.15 is 300. Be careful that because this is a 15% off and the 15 equals the 45, that our multiplier is just 0.15. Okay. The second one is saying that we've decreased by 35% and the amount is now 1,500. What was the original amount? So our original amount times by our multiplier. Now we've decreased by 35%, so 100 take 35 is 65. It's going to be 0.65. And that equals 1,500. So x will equal 1,500 divided by 0.65. Which is... Ooh, gosh. 2307.69. Again, only to 2 decimal places, because we're working with money. Right. This bottom question is actually pretty involved, and this is the first kind of question that I would expect to only be on the higher tier, or it may be at the very end of the crossover. We got a train ticket which has increased by price by 0.5% each year. After 2 years, the price has gone up by £4. Now, if you remember from our repeat percentage slide, we can say that 0.5% squared, because it's gone up a year for 2 years, is going to be equal to £4. Now, 0.5% is going to be 0.005 as a decimal multiplier, which is equal to the £4. Okay, so we can actually use the style like above in the very first one. We can say that x times by 0.005 squared equals 4. So x will equal 4 divided by 0.005 squared. Which gives us a ridiculously large number. I should probably have checked that this number was reasonable before using it, because my train ticket is worth nearly as much as a house. I don't know why I find that so funny. I don't know. Anyway, yeah, that is the question. That is how you would work that out. It's just that I really should have checked the numbers to make sure that it was reasonable. Right. Anyway, let's check our most difficult of the questions. Okay, let's have a look at the ones which we would consider to be hardest. Okay, now these kinds of questions are actually some of the questions which cross over between GCSE maths and core maths, It's qualification that you could do in sixth form, which is not A-level maths, but it's still maths that you might want to know if you are thinking about courses in business or in finance, or perhaps supplementing some of your maths within economics or geography, psychology, anything like that. It's quite good, and that's not just me saying that as a mathematician. So let's take a look at these. I'm only going to take a look at these when there aren't similar ones for you to try. So if you want to try these out before I go through them, this is your chance to pause now. Okay. So let's read through these. We've got an amount is invested at 5% interest over the course of 3 years. So that kind of sounds like a compound interest question. At the end of the investment, there is £2,540 in the account. Now, that is not like our normal questions from before, because we're told what the final amount is, and we want to know how much was in the account at the start. So this is actually a reverse percentage combined with compound interest. Am I going to do anything different? No. We're investing at 5% interest, which means that our multiplier to increase by 5% is going to be 1.05. This is happening over the course of 3 years, so I'm going to put to the power of 3. At the end of my investment, there is 2,540. Okay, and we're trying to work out what is that original amount. Now, if you remember from our previous slide, 2,540 divided by 1.05 to the power of 3. Okay, now, that is all I type into my calculator. 2,540 divided by 1.05 to the power of 3, and I get an answer of £2,194.15. 15 pence, again rounding to 2 decimal places. The way that this question is different to the one that we saw in our previous slide right at the very bottom is because I'm telling you that the final overall amount, which includes the original investment, now the fact that it includes that original investment means that we've got the 1 point in our multiplier rather than the 0 point that we had in our previous question. And the reason why we had that 0.005 is because the 0.5% increased over 2 years was the £4. Okay, the price of the ticket, including the increase, wasn't £4. It was only that increase, which was £4. Okay. Checking out this second question underneath. Okay. We've got the value of a car depreciates every year by 7%. And we want to know after how many years will the value be less than half of its original value. Okay. So this is a question where we're going to have to perhaps use a little bit of trial and error. Okay. But let's fill in what we can. We're depreciating, which is a posh way of saying decrease, every year by 7%. So that as a multiplier would be 0.93. What we don't know is after how many years we're doing this. But we do know that we've got an original value. That should be a multiply. And we know that our final value should be less than half of the original value. Which, okay, that's interesting. I want to know what power I need to make this work. Okay. So, let's see what we can do. We could rearrange this to say that 2x times 0.93 to the power of something is less than x. And then we could divide both sides by x to say that 2 times 0.93 to the power of something is less than 1. And all I'm going to do now is I'm just going to try a value and see what happens. So 2 times 0.93 to the power of, let's try 5. That gives me 1.391. So 5 was not enough. Okay. So we need to try again. Let's try 9. Ooh, that was close. I don't actually know the answer to this. I am working this out as we go. Again, not enough. We want this to be less than 1. So let's just increase that by 1 more to give us 10. Bingo. There we go. So after 10 years, we would have less than half of our original value. Okay. Now, at GCSE level, we can only do that by trial and improvement. There is no algebraic, efficient way of doing that without gaining some knowledge from AS level and A level maths. Okay, in order to work out what that power would be exactly, we would need to know something about what we called logarithms. Okay, but at a GCSE level, we don't need to know what logarithms are. We would only be expected to look at this as a trial and improvement situation. Okay. But I would say that those are probably the more complicated side of our percentages. Okay, I wouldn't expect things to get more complicated than that. What you might have to do is use percentages combined with other aspects of maths. So you might, for instance, need to combine percentages with fractions or with percentages and ratios. Okay, so then you've got a mixture of all 3 different things. Okay, remember that if you're equating percentages and fractions, the percentages are fractions out of 100, literally percent, meaning out of 100. Okay. So that is a comprehensive look at percentages, okay, in about 38 minutes. Okay. I've attached a worksheet to go along with the this video. If you're in my class, if you're watching this on YouTube, then I would suggest you Google for Dr. Frost full coverage percentages, and you will get the same questions. Okay. But that will do for now, I think, and hopefully that gives you more than enough to think about in terms of preparing for your assessments when thinking about percentages. I will leave it there, and see you next time.